Hello everyone, welcome to our virtual construction site. Here people are working every day to get the job done. But not at all the time things goes smoothly. Unfortunately, accident happens quite often in construction site. The working conditions are sometimes harsh for humans and the construction approaches have not evolved for decades. This is only the tip of the iceberg of challenges construction industry face. We are having significant problems from safety point of view, productivity and efficiency of the construction projects. Co-robotic construction and automated solutions are emerging technologies that are finding their way into our industry as a remedy to these challenges. I'm introducing you to Spot and Mavic. They are the pioneers of robotic solutions in our sites. They are being used to monitor our site and capture data for engineering analytics. They are suggesting promising capabilities in maneuvering into the chaotic sites and enables the automated data capture. But there is a small problem here. These robots are mostly finding their way from other industries into construction. Therefore, they are not as good as we expect in detecting, identifying, and, in a broader sense, perceiving the construction world. For example, it is very probable that they face challenges understanding what excavator is doing or why humans are working in very close proximity to the excavator. To solve these issues, researchers are working hard to find a way to promote the human-robot collaboration in construction industry. Most promising approach of recent research is to use the power of artificial intelligence and specifically deep learning to enable the human-robot collaboration. Deep learnings are mainly comprised of three parts: labeled dataset, algorithm itself, and the objectives of the algorithms. Through the recent years, performant algorithms are developed and well-defined objectives are curated. However, the data limitation has remained a challenge and become a bottleneck in real-world deployment of deep neural networks. To tailor the data-greedy deep learning algorithms to our need in construction industry, we need huge amount of labeled data that can cover a wide variety of situations. But we simply do not have this data. The question we are raising here is, what if we can fool the deep learning algorithms? In other words, can we use non-real but real-looking data to train deep learning algorithms? I'm Ali, and here me and my friend Muhammad Ali are presenting you the framework of Fake It Till You Make It. In this framework, we are trying to answer the crucial question of, can we train deep neural networks using synthetic data? Through the recent years, the computational graphical engines are empowered enough to create non-real images that are not distinguishable from their real counterparts. To distinguish between real and synthetic is challenging for humans, let alone for computers. Computers are analyzing the images as grids of numbers, and this approach of handling images encouraged the success of synthetic data in training computer algorithms. Computers are not seeing images as we humans do, and it might be easier to fool them, to learn from non-real but real-looking images. To test this hypothesis, we're proposing the framework of Fake It Till You Make It. In this framework, we're collecting 3D avatars that mimics the human workers and the 3D point clouds or IFC files as the basis of our virtual construction site. Since the rendering is done in graphical engine, we have access to the precise and accurate information of all elements, which can be used as ground truths or labels in deep neural network training. This framework offers the potential of seamless creation of synthetic data by just clicking a single button on your computer. Here we can see some sample of synthetic data generated by this framework. As you can see, different avatars are present in the scene and doing different construction activities. The extracted ground truths includes the 2D and 3D bounding boxes and key points. We can also generate depth maps. This framework also enables us to extract semantic segmentation of workers seamlessly. Development of this framework paved the way toward realization of a bigger goal, imitation learning from synthetic data. Imagine that a robot is deployed in real world. An onboard DNN, which we call it a student DNN here, would analyze the incoming data. Probably we will have some inaccurate or uncertain predictions. By capturing these false predictions, we can simulate the same situation, but this time in virtual world, and retrain our robot. This process is exactly like training a real human to be a construction expert. At the very first day of development of robot, it will face many challenging situations. But during the night, when the imitation learning engine is running, the robot is retrained to tackle the challenging situations. Retrained robots would improve day by day and can handle the challenges better than before. By passage of time, the robot will be highly trained like a construction expert and will be able to collaborate with human workers on site. The most promising value that this framework brings is to promote human-robot collaboration in construction industry. With successful development of human-robot collaboration, most physically repetitive and unpleasant tasks would be taken over by robots, while humans focus on tasks that require dexterity and improvisation. This major shift in role of workers will bring us a safer, more productive, and inclusive construction industry.